Well, hello again everybody, and welcome to part 3, the final part of our Mind the Gap video. So in part 1 of the video we built this little circuit here to feed the primary side of our ignition coil with some pulsed 12 volt DC. Oh Jesus! Christ on a bike, I just got a right belt off this coil. And in part 2 of our video we did a teardown on the ignition coil that I removed from my truck after it broke down.
So here we are, come to help Chris get his truck running, and it's not running and we broke down. So he's gone home to get a coil. Hopefully that's all it is, and we're running soon.
In fact, let's just disconnect this, we don't need it now. This is where the transformer, this is where our coil has failed. And we also had a go using this Hantek current clamp to have a look at the primary current in our ignition coil. I know bugger all about it, I've just bought it. Here's some instructions, I'm not going to read them at the moment because I never do. So you can see the falling edge of our current waveform here. It's not sharp, it rolls off very gradually. Well, I thought for this third and final instalment we could actually have a look at some of the other parts of the ignition system. Right then, let's get started. Oops. Kids don't do this at home, as if they'd want to. So in the first video we built this little circuit, and it uses this 555 timer here to operate this relay, and this relay has a set of contacts on it and they open and close at about 20 times a second, and what they do is they deliver a pulse of DC current to the primary side of our ignition coil, and our ignition coil responds to those pulses of DC by giving a very high voltage output. It comes out of the top here, and we were measuring that, and I got a right nasty electric shock off it, didn't I? Stupid me. But of course in a real automobile you don't have a set of relay contacts like this, and you certainly don't have a 555 timer generating the ignition sequence. Well, I've got no doubt that if you're a man of a certain age you will definitely recognise this. And I've actually removed it from its natural habitat, which is living in the engine bay of my truck. So what we've got here is an automotive distributor, and the distributor does quite a few different things, and I thought we could have a look at that today. Now, one of the most important jobs for our distributor is actually to replace our 555 timer and our set of relay contacts. So let's have a look at that bit first. Now normally, as I said, this would be installed on the side of the engine, and I don't know if you can see that, we've got a shaft here. Well, this shaft here sits down, it sticks into the engine, and it's got a cogwheel on the end of it here, and this cogwheel in operation gets turned by the camshaft in your engine. If you don't know what a camshaft is, go and find out. But naturally this shaft would be spinning, being driven by the engine, so that's what that tooth wheel does here. It's driven by the camshaft, and then we've got almost like an old-fashioned screwdriver blade at the bottom. We've got a square bit, and the purpose of this square bit, this would stick down into the lower part of the engine and would fit into the oil pump. So the purpose of this little tang here, I guess you'd call it a tang, is to spin round and drive the oil pump, because an engine needs pumped oil lubrication. But I'm going to take the lid off the distributor now. Just unclips, and of course they make it very easy to unclip, and there's a reason for that, and that's because what's in here needs almost constant adjustment. And I'm just going to pull off this little fella, we'll come back to him later. So we've got a set of contacts in here. Now one side of the contact is actually just effectively screwed down to the body of the distributor, because in old cars and stuff like that the actual bodywork is ground. Well, some cars used to use a positive ground system, but the most widespread grounding system would be a neutral return. So all the bodywork, the metal bodywork of your car, is probably connected to the minus side of the battery. So one side of this contact is permanently grounded via these screws here. It's actually screwed to the body, and then the other side of the contact goes through a plastic insulator and comes out of this wire here. But this contact opens and closes. So the moving part of our switch contact presses against this, well, it's actually a cam. It's a hexagon shaped cam, and it's got 6 lobes on it. Now it's important to remember that there's 6 lobes, and on my car it's got 6 cylinders. If you had a 4-cylinder car you would have 4 lobes, it would be actually a square shaped cam, but this is a hexagon shape because I've got 6 cylinders. And if I rotate this shaft now, I'm going to rotate it from the back end, hopefully you can see that the switch is opened and closed. So every time one of the lobes on this 6-sided cam makes contact with the side of the switch body, it opens and closes the contacts like that. And every time that contact does open and close, what it does is it actually sends a pulse of current to the primary side of our ignition coil. So what I'll do to prove that, I'm just going to get a light bulb and connect it to this contact. So I'm just going to take our ground wire here and I'm going to connect it to the 0 volt connection on our power supply. So there we go, stick that in there like that. And then I'm going to get our bulb and I'm going to just wrap it around this crimp here, just temporarily. Hopefully we can get a connection. I have to just put a clip on there to hold it. Okay, hopefully that will do. And then the other side is going to go to the plus side of my power supply, so let's clip that on. So all I'm going to do now is I'm going to turn this input shaft to the distributor, and it's going to make this cam rotate here at the top, and it's going to open and close our point set. So our switch is in the closed position now. I'm just going to rotate it till the lobe on the cam makes contact with the body of the switch, and that's going to turn off. Now it's onto the flat section of the cam, it's going to come back on again. Now it's onto one of the lobes, it's going to turn off. And on and off. And just noticing, it does actually appear that the little pulse coming out of our lamp here is not totally symmetrical. So I think that these points probably aren't very well adjusted. And of course that was one of the big drawbacks of the old-fashioned distributors like that. Well, if you're like me, a man of a certain age, and undoubtedly part of your child memories will be your father on a Sunday morning, well, typically he would spend the time between getting up and going to the pub, outside on the front drive fiddling with the car. That was one of the problems with these old distributors. These points gaps here would need adjusting because they would wear out and it would make them unreliable, and because the points are constantly wearing out by a combination of kind of mechanical friction and force and just the effect of the arc pitting the contacts, metal is eaten away on these contacts, so you'd have to get a screwdriver and you have to actually adjust the gap here, and it was a very important little adjustment to make your car run properly. This point, they used to call it adjusting your points gap. And yeah, as I say, on a Sunday that was a favourite pastime of all men before going down the pub. So you can see here that we're delivering a stream of pulses to our lamp which is making it flash on and off. So the next logical thing to do is let's take the bulb away and let's install our ignition coil in place of the lamp. Okay, so I've put a piece of red wire on here, that's going to be our positive connection. And I'm connecting one side of our switch here to the minus connection on the coil, and put the screw on there. And of course we need our sparky zappy thing, so let me get that. I'm desperately hoping to avoid another electric shock today, but we'll see how we go. Kind of an occupational hazard messing around with distributors. Anything to do with car ignition systems. I'm sure if any of you have played with them and adjusted them in the past, we've all had the odd belt from them. Okay, so we'll take the positive side of our power supply and we're just going to connect it to the positive supply of our coil. So now what I'm going to do is I'm going to rotate the cam again. I'm just going to grab the back of the distributor and I'm going to spin it round, and hopefully, he said, hopefully you should see this sparking. Now one of the problems you used to get with this arrangement is that typically you would be sat in your car listening to the shipping cut forecast on Radio 4, and because you had your radio on, you'd have the ignition switched on, And of course you wouldn't have bothered to check what condition these points were in, because when your engine stops, these set of contact points here, they could be open or they could be closed. Now in a perfect world these points would be open, in which case there is no current being delivered to the coil. But it was just as likely, in fact in many ways probably more likely, that when your engine was stopped it would actually stop at the top of the compression stroke. So actually these points would be closed, and because the points are closed we're delivering current to our coil here. You can actually see we're delivering about 3.7 amps. So with our points in the closed position we've got 12 volts being delivered to our coil, and you could see that there was about 4 amps behind it. Well, 12 times 4 is 48, so this coil would be sat here trying to dissipate that current and that voltage. That 48 watts of power would dissipate off as heat, so the coil would get red hot, and it wouldn't be unknown for this coil to get so hot that it could fail internally. The oil would get red hot, and the windings could be damaged. So not only would the coil be damaged, you'd also get the points here, these switch contacts. They again have got 4 amps of current going through them constantly, and over a period of time, because these never get a rest, because these never open, the power is always constantly applied, these would get hot, and again they could be damaged, as could any of the winding. So as you can see, that wasn't a great arrangement, and it was pretty common to end up with a flat battery if you weren't a bit careful. So if we have a look inside our distributor, you can see that there's this metal component which it doesn't look like a capacitor, does it, in that it's just like a canister, and it's got a wire coming out of it, but it's not got like a wire on either side like a capacitor has. But that's exactly what it is just a capacitor. The wire here is one side of the capacitor, and the metal can forms the other side. In fact, here's one I prepared earlier. I'll tell you what, it might be interesting just to use the capacitance meter just to see what the actual value is, because again, these automotive components, they don't actually help you. They don't tell you what the capacitance value is. I think I estimated, didn't I, that a good choice would be about 220 nanofarads. Certainly that's what I installed previously. That was a 220 nanofarad. So let's just check that. So as I said earlier, this black wire here, that's one of the connections, and the body is the other connection, so I'll just clip my little probes onto there. So there's one on the wire, put one on the body now. So it looks like when I built the little test board, I had a fairly good guess at the capacitance value. It was certainly in the ballpark. This is around 200 nanofarads, and I originally installed about 220. Now perhaps if I owned a motorbike with its single cylinder engine, as opposed to a Chevy truck with its 6-cylinder engine, all we'd actually need to do is connect a length of wire between our ignition coil here and our sparking plug, and off we would go. But unfortunately that isn't going to work with the Chevy truck, because we've got 6 cylinders and we've only got one ignition coil. Now unfortunately it wouldn't be practical for us to connect our 1, 2, 3, 4, 5, 6 spark plugs. Where's it gone? Over there, you didn't see that, did you? Bring it back. There we go. Have another go. Okay, so it wouldn't be practical for us to connect our no, do that again. Third time's the charm. What is it? Once for luck, 3 times. Oh, unfortunately, it wouldn't be possible for us to connect our ignition coil to our 1, 2, 3, 4, 5, 6. Did I get that in? Why does my arm always go over there? Bloody thing. So where were we? Blah 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 something blah blah. So blah blah blah. So of course, if we had a motorbike, we'd only have to connect up our one spark plug, and that would be absolutely fine. But unfortunately, I don't ride a motorbike. I've got a Chevy truck, and the Chevy truck has 1, 2, 3, 4, 5, 6 cylinders. So of course there's nothing stopping us getting a piece of wire here, and what we could do is, just very crudely, I'm just going to join all these together. So of course we could connect all our spark plugs together like this, but that wouldn't be a very good arrangement for a number of reasons. So when we were using our little spark gap here, we just had a single gap, and you could see that the spark looked quite powerful. It was quite a bright, angry, loud spark. But of course, if we were to try to share that spark between all of these 6 sparking plugs, it would effectively be the energy within the spark would be watered down. And of course the problem would be is maybe the spark could actually be too weak at any individual plug to actually ignite our fuel and air mixture. So that wouldn't be a good arrangement. We'd actually be wasting some of our spark here, because actually only one of the pistons would be ready to fire. Maybe this piston would be ready to fire, but these other pistons aren't ready to fire, so kind of it's a waste of time supplying them with spark because they're not ready to accept it. The fuel isn't there. So what we actually need to do is to connect the spark from our coil to each of our plugs in a certain sequence, and depending on what sort of engine you've got, that sequence may be different, but for the engine that I've got, the sequence is, well, let's assume this first one is spark plug 1, so basically we would need to connect spark plug 1, and then the next one in line is actually cylinder 5. You would be igniting the fuel in, and then after cylinder 5 we need to go back and do cylinder 3, that one, and then it goes to cylinder 6, and then back to cylinder 2, cylinder 4, and then we start again back to cylinder 1. So what we really need here is some kind of single pole but 6 position switch. We need something that's going to distribute our spark to each of these plugs. Now the clue's in the name. What we actually need is to revisit our old friend Mr. Distributor here. At the start of this video I know how impressed you all were with my rather fetching headwear. Well, that was actually something that they call a distributor cap, and naturally that would live on here, so let's just put that on. So that fits on there like that. But what I'm going to do is I'm just going to take this off for now, and you can see that round the outside we've got 1, 2, 3, 4, 5, 6. We've got 6 connections here, and it just so happens we've also got a centre connection. So I think it'll all become very clear when you see how this goes together. So what we have here, we're going to take the centre connection from our coil here, and that's going to go to the centre of the distributor there. And what we've got in there, we've got an electrode, and then you can see that we've got effectively 6 switch positions there. Can you see into the cap? Let me bring you in. So you can see there we've got an electrode in the centre, and then we've got 6 electrodes around the outside. Now these 6 electrodes that go around the outside, these actually connect to our spark plugs. I've actually labelled up these plug leads, so there's number 1. Let's find number 2. There's 3. So there's another thing here that I wanted to show you. Here's a spark plug lead for cylinder number 1, and I thought it would just be interesting to actually look at the resistance of the cable, because it might be surprising for some of you. So I've just got our fluke meter set to the ohm range here, and I'm just going to go to the wire, and I'm just going to try and get on the centre electrode of the spark plug, because that's where our spark comes out. And you can see there, hopefully, that the reading is about 5.5k, or 5.47 to be precise, 48, 49, flicking around there. Now if we take a piece of wire here, here's just a jumper cable I've got to hand that's about the same length. Let me just see if I can hold that on there. The resistance of this little cable here is coming up as about 2 ohms. These aren't very good jumper cables. And I think there's a bit of resistance in here as well, 0.5. So it looks like maybe the resistance of this cable is maybe 1 ohm or something like that. But that's certainly a lot different than the resistance of this cable, which was about 5.5 kilo ohms. So what kind of shenanigans have we got going on here? I mean, these are pretty poor wires, aren't they? I mean, they're not very conductive. Oh, 5k, that's rubbish. So I'm just holding up one of our ignition leads here, and I've just pulled back the rubber cup on it, and I'm hoping you can see that it's you can see some white insulation material in the middle, and then you can see a piece of black material. It's not coming out very well. Can you see it, like a little black sausage sticking out? Well, that black material in the centre, that's actually our conductor, and it's not a piece of wire. What it is, it's lengths of glass fibre, you know, like fiberglass, very thin strands of glass. And what they've actually done is they've coated them in carbon powder, and it's that powder which is acting as the conductor. So it isn't a solid piece of wire in here, it's not a single core metal wire, it's lots of strands of carbon coated glass, and that's how they do these. They actually just strip back some of the silicon rubber, because the outer jacket is quite a thick silicon rubber, and what they do is they just expose some of this central conducting material, and they fold it back on itself here, so it folds up and it actually folds back onto the insulation here, and then they just crimp it down. So that's how these are made up. These are just a crimped end that fit onto the end of the spark plug. Well, this is the distributor end, this is a male end and slides into a cup on the top of the distributor. Now, back in the day when they first started making ignition leads, they didn't have this fancy conductive carbon material, and they actually used to make them out of just used to be just like a single core, a thin copper wire which was heavily insulated. But they went away from doing that, and the reason they went away from doing that was really because of the radio. Radio systems started to be installed in automobiles, and what you would find is if you had these solid copper ignition leads, they would actually radiate a lot of radio interference, so you couldn't drive down the road without blocking out the radio, and you'd also block out the radio for anybody in nearby houses. So they thought, well, this is not very good. So they needed to limit the instantaneous, the energy. They had to back the energy off a bit from these modern, advanced, high-powered ignition systems. So the way that they damped that down is they actually used, they started to replace the copper wires with these less conductive, much less this 5 kilo conductor material. So that's why these aren't solid wires. They're called suppressed ignition leads, and they were done to actually prevent radio interference. Probably not such a concern with the advent of digital radio and VHF, but certainly if you would listen to AM radio, you used to be able to hear quite commonly, somebody would ride past on a bike or something, you would hear the ignition sound as they drove past in the car. You don't really hear that anymore. Maybe it's because nobody seems to have AM radio. Now, for the purpose of our video, I've just got a piece of sellotape here with kind of the letter 1, just a white piece of paper glued on, and I'm just going to arbitrarily choose one of these positions on the cap, and I'm going to say that that's going to be the spark plug lead for our cylinder 1. So we'll put that on there. It might not really be on this position when it was installed on the engine, but I'm just going to assume a position for now. So there's our number 1, and I'm just going to go ahead and I'm going to connect our leads. So where's our first lead? Is that number 1? Okay, there's number 1. It's gone in. Now, you might assume that the next lead I'm going to connect is I'm going to connect lead 2. I'm not actually going to do that. I'm actually going to connect lead 5. Now I need to find lead 3. Lead 4. Oh, no, not lead 4. Got it wrong there. Lead 6. I'm sure some of you are ahead of me. You know why I'm doing it in this sequence, don't you? But I'll explain later. Lead 2. And the last one to connect, which is going to be spark plug number 4. So we're going to get our 40,000 angry pixies jumping out at the top of the coil, running down this central conductor at high speed into the distributor cap, and they're all going to sit there on that centre electrode there. But we need some way of getting those angry pixies from one side of here to the opposite side of the cap there to actually the spark plug lead. And the way we do that, we use something called a rotor arm, which I'm now looking around my bench for. Where's it gone? Oh, there it is. So here's the next part of our little ignition puzzle. This is what they call a rotor arm. So we'll take a close look at our rotor arm. So if we just turn it over, you can see there's actually like a cup shape here. Now this fits on the end of the shaft in the distributor, and you can actually see if you look down into it. Let me get a lamp. Hopefully you can see it's got a keyway installed inside. It's very important that this keeps exact position. You wouldn't want it just pushed on because it could lose alignment, and the position of this is very important to the running of your engine. But if we just turn it over and look at it from the top, you can see that it's got this this metal springy jobby on top of it, and then a piece of copper at the end. So this metal spring here, this actually presses against the central electrode in our distributor cap. So that's where we're going to get our power from our ignition coil. It comes into the top here and presses against this this top here. So this will become live with our 40,000 volts. And then what happens is the voltage runs down the arm and it leaps off the end of the arm here. You can see it's like a copper material. The high voltage will leap off the end, and then what it will do is, let me bring in the distributor cap, it will leap off the end of the cap and it will jump across onto one of these wires here, which are, sorry, one of these electrodes which is connected to our ignition coil. So the rotor arm bridges between the central electrode here and these electrodes around the outside which are connected to the ignition leads. So it will go something like that, and this will spin round. So you can see I'm lining up with that one now where my finger is, and it'll line up with that one, then it will line up at that one and line up with that one. When this rotor arm lines up with one of the sparking plug leads, the cam on here will be arranged such that the points open and close like that, and that will make the ignition coil deliver its 40,000 volts. It will spaff its 40,000 volts out, which will jump onto the end of here, shoot across, and it will go onto our appropriate ignition lead and spark our plug. I wonder if we can give that a try. Let's try it. I've never tried that. Let's do it. I'm sure you'll all laugh if I end up getting another electric shock. And I'm afraid I'm probably not going to be able to get these in sequence. In fact, let me see if we can get them in sequence for our firing order. So where was spark plug 1? Was that it? Anybody keeping a track? No, not that one. There's 1. So here's our number 1. Let's get him down here. Okay. I think this is going to be a bit tricky to film, to be honest, but we'll have a go. So there's 1. So what do we want? We now need spark plug lead 5. I think that's 5. 5. Okay. Next one is 3. Come on, number 3. Next one is 6. Where's 6 gone? I think 6 should be a long one. That's 6. 4. 6. Okay. Then 2 and 4. There's 2. Finally, number 4. So one side of our spark plugs where it would actually screw into the engine, I've actually replicated it by being screwed in by strapping all these to ground. So we just need to get our ground connection here, and I'm going to put that on there. It's quite important that this doesn't come off. And now I'm going to connect that back to the negative side of the coil here. So I'm spinning this now, and we're actually getting these firing in their sequence of 1, 1, 5, 3, 6, 2 and 4. I don't know if it'll come out on camera because it's not very bright. So hopefully we should get these firing in sequence. So that one just fired. That one. Oh, then that fired again. Seem to have a little bit of a problem with our first one. So hopefully you can see that these are actually firing in sequence now, and the sequence is actually 1, 5, 3, 6, 2, 4. But I've actually arranged these leads so they actually look as though they're going in, you know, from 1, 2, 3, 4. But they're not. The actual firing sequence is 1, 5, 3, 6, 2, 4. That's quite interesting. It's not something you see every day, that, is it?
I'm blind.